Thank you. I'm back. My name is Ciaran Regan from the University of Scuba. So we're talking about another work we did, and this time it's on modeling human-like emotions. So instead of just capturing the way an individual speaks, actually trying to measure if we can get responses from an LLM that kind of capture the emotion that a human would have. So the question is, how can we create agents with human-like emotional responses? So this was kind of motivated by this example. Here we see a picture of a park, and on first glance, you might think, oh, it's a peaceful, scenic park. And when you give this image to an LLM, it's going to say peaceful, scenic park. But then what happens if I show you these images? So first, it's someone playing in the park. And then after that, it's someone playing in the park again. And then finally, it's the picture of the empty park. And it goes from being a peaceful park to a very lonely park. And we thought this was interesting. And we wanted to design an architecture that kind of understands this. And so we came up with an agent architecture inspired by the appraisal theory of emotion, which is a cognitive approach to understanding emotions. It claims that events and the individual's appraisal of the event is what triggers the emotional response. And it can explain how different emotions emerge from the same event for different individuals. And it kind of highlights the importance of context in emotion. So we propose the following architecture for our agents. So they take an image, and the image gets captioned and converted into natural language. And then there's the following architecture. And so the first step is we create this thing that we call the norm. So the norm is kind of there to capture the expectation of the avatar. It's what the avatar kind of expects. So to do this, we retrieve the avatar's memories. So like before, we have this kind of memory stream or memory bank that holds all the memories. We retrieve relevant ones and salient memories, and we summarize them, asking what high-level insights can you infer given these memories? So this creates this norm object, which we're going to use later. Then using this norm, we create what we call a contextual understanding. So we compare the most recent event perceived with the norm to see, was this unexpected, like that, to kind of get the understanding of the event in context with what was expected. So given the background context of the memories, how can we interpret the new situation? And then we use this in the positive and negative affect schedule. So this is a way of kind of measuring emotional response. So it's a test where you would give it to a person, and they're asked to rate these 20 emotions on a scale of 0 to 5. And so it kind of gives an idea of either the positive or negative emotions experienced by the person. So we administer this test to the large language model. And in particular, we measure the change in affect. So we first ask the LLM this PANAS test without any context. Then we give it this contextual understanding, and we get its score, and we measure the change in score. So now we have a norm and this contextual understanding and the PANAS results. And we store the memories. This was kind of interesting in a graph database. So there's these memory objects that are connected to norm objects. And depending on the way we actually retrieve memories, we get these different memory structures, which I thought was very interesting. So for example, if you have recency as the kind of most important factor in retrieving memories, you get this kind of a straight line, which is kind of cool. And then in this context, this image is then interpreted as a lonely scene with no people playing. And we get a PANAS score of positive affect 5 and negative affect of 30, where each number is a maximum of 50. So we proposed an experiment where we took situations from Emotion Bench. So Emotion Bench is this benchmark where it has situations which came from some psychology papers. And they used, in the Emotion Bench paper, they used an LLM to kind of rate the emotional response in these situations. But we wanted to create episodic memories that we could feed into our architecture. And so we turned each situation into a 5-scene story using GPT-4. And these stories are designed to be objective and neutral. So the emotion only comes from the agent's interpretation. And then we run the architecture using GPT 3.5. So here's just an example of what I mean when I say situation and story. So one of the situations could be anxiety. You are fearful of the upcoming presentation you have to deliver. This is actually from the emotion benchmark. Then we put that through GPT-4 and we get this kind of scene. So I look over the presentation materials thoroughly, checking each piece of data, and then it kind of progresses, and then I commence my presentation, advancing through the slides. So then we compare our proposed architecture with the same architecture with no context and the scenario only, so without the episodic memories, and the human responses scenario only, so no episodic memories. And the kind of key result that we found is that there was an increase in negative affect using the norm. So both models still fall quite short in alignment, but we found the increase in negative affect to be quite important because the large language models, again, are kind of fine-tuned to be these really positive responding models. So we thought this actual increase was quite significant compared to the other two so far. And then I mentioned I want to talk about applications. So this work was supported by Mixi Inc., which is a Japanese social media company. And they were interested in building a recommendation system. So they have a service that's like Instagram where you can upload pictures. And they wanted to have a recommendation system that kind of recommends images based on emotion. So they wanted to kind of understand the emotion in each image. So our architecture was used for this. So for example, there's a picture here of a man and a daughter. And with our architecture, it extracted a man and child appear to be enjoying their time together as they hold hands and walk through the field. And this memory can be interpreted as a bonding moment between the two of them or a shared experience. And in particular, we can see which memories were used to create this response. So there's pictures of them together, and it knows that in the past, they were also together, so it can kind of interpret it as a family kind of bonding moment. And then finally, I just want to talk about the safety and ethics of this. So I think there's a lot of ethical concerns with these kind of generative agent architectures. One of them, for example, is dead bots, which is the idea of creating AI avatars for people that are dead and then talking to them as if they're alive. And that also comes with consent issues. So really recently, Scarlett Johansson and the OpenAI voice. Yeah, so there's a lot of ethical concerns here. I really think, yeah. So to conclude, generative agents are becoming increasingly human-like, and they're also at the same time becoming more prevalent in society. And the proposed architectures that we actually show are kind of contributing to this. So they're showing promise in capturing individuals' communication style and modeling human-like emotions. The applications are vast, but must be balanced with safety and ethical concerns. Thank you.